So we will consider the data as like the element. So student, for example, table, student database is the collection of the data. Why? Dr. E.F. code, someone pick up the set theory to manage the data or data model. Why? Looks nice. As
they have
you
to be related because they have to be unique or related.
unique and related. Yes, no, I don't think so. The reason why Dr. E.F. code was someone pick up the set theory to build a database model is actually math is the subject, which is perfect. Using the equation, we can prove anything. There are a lot of the theorem and theory, and that has been proved and used a lot. For example, you know the intersection and the union and minus and some other set theory information. Most of the operation that you are using currently in your computer science or the math actually from the set theory. What is actually number? Have you ever thought about what is the number? What is a number? Number is the basic of the math. Number is a set. If you major in the math, probably you should learn what is the number. Number is, for example, natural number. Natural number is consists of whatever. And real number is a set. It's a definition. Because number, especially number, is infinite. You cannot show all the example of the number. Nobody did so far. Nobody can do because it's an infinite number. Then how can we use such an infinite number? Because we define number as a set. This is a natural number. This is an integer. This is a positive integer. Then we can do such a operation. And such a definition can be used for database. That's the benefit of the using database. So it's already thrown in the proved the theory. So we will learn such a data model. So for the data model, we will select the entity relationship data model. This is a conceptual model. This is not the computer system model. So first, we will start the database design with ER modeling, or it's a ER modeling. Okay. As we have discussed, the data model consists of the two parts mainly. One is a conceptual model that we have discussed. Then physical model is based on the output of conceptual model. So somebody design the student information as a student data model. So student consists of a last name, first name, and social security number. That's it. So using that information, I'd like to build the database on a computer. That is a physical model. At that time, you need what? DBMS. You need to select the software. Because that's the only way to utilize the computer research. Even though you have the very fancy, nice data model for student, how can you create such a student database on my computer? Using software, that is the DBMS, Oracle DB2. At the time, depending on what types of the database model, what types of the DBMS, it's a slightly, sometimes hugely different. That is called the physical database model. First, we are going to cover conceptual model, then physical model. We will cover both of them. Actually, the third one is not very important. The Dr. Elmersly, who authored this textbook, this is his idea, but not generally used. So don't worry about too much. Eventually, we are going to create the output of the database design is the database schema. What is a schema? You probably heard a lot in any computer science subject, right? What is a schema? Design of description. And good answer. Anyone else? Structure. Yes. Good answer. What kind of structure? Actually, this is not structure. It can be structured. Yes. It's a description. She answered correctly. It's a description. For example, I'd like to build a university database, which means I'd like to build something. I don't know what that is yet, but it's something that describes university, right? So schema is kind of this description. Is what I did. You don't need, right? It's a description. Okay. So it's sometimes it can be considered as the boundary. So this is a university schema, means all information, all description about the university will be inside this boundary, inside this schema. Okay? Sometimes it's very hard to understand from that schema. So we can represent this schema or the description using diagram. For example, this one. This is a diagram. So anybody, even though you do not have knowledge on the database, you can understand the university database, right? This is a university database schema or university database boundary. It consists of a student course prerequisite section and grading report. And for example, student has name, student, number, class, and major, and so on. Our goal is to build such a database schema. From what? From description or from your customer requirement. So I made a contract with my customer. She wants to build a database for her nail shop, for example. So she is the owner of the nail shop. Okay, then she will ask, she doesn't know anything about the computer or the database or system. She wants, I'd like to manage my customer, how often they are coming, and also how much they contribute for my benefit, and what is the daily income and the monthly income, what is the tax. I'd like to manage this one. Please build a computer system for this. At the time you decide, because her customer is so huge and large, we decide to use the database to manage such a data at the time. First, design our database like this way. Okay, this is our goal. But we are going to learn how to build this one first time. That is conceptual design. Eventually, it will be like this one. It's called the database state. Database state means database schema plus real data, like this one. That is called the database state. It's a current state. It's a current snapshot of the data. So this is the final goal. Okay? This is just a diagram. It doesn't represent all the constraint or model in the database, but it's just a representative. So your goal is to build such a database state. Our current modernized database is based on the 3 schema architecture that we are going to discuss right now. We don't have time, so what's the time? 4:22. Let me have the 5 more minutes because we start a little bit late. So if you have any other class, you can leave anytime. So 3 schema architecture is like this one. So it has external view, it has a conceptual view, and it has an internal schema. So I already mentioned of the several characteristics of using database approach. One is the program data independence. What does it mean? Program data independence, which means even though data structure is changing, program no change. It's independent. How can we preserve such a program and data independence? So somebody proposed it's actually ANSI standard. It's a standard architecture of the database. So DBMS, when we call the DBMS, that's satisfied with this structure. One is it should have the internal schema. Internal schema means it's how to store, how to design the data structure physically. Like we have file system. This is the file system. From first byte, this one will be used the folder, and file will be created, So first file, this one will be used the student and so on. It's an internal level. Actually, you don't have to worry about how to build the internal level. Who is in charge of to manage such an internal level, internal schema? DBMS software. So Oracle developer, they developed the DBMS software. So to define the internally how the student data is stored physically. Sometimes it's continuous, sometimes it's separated. I think most of the idea comes from operating system that you learned in the probably chapter 9, 10, 11. If you already took the operating system. That is internal schema. But that should be connected to the conceptual schema, which means the student, user will access the data using this information, name, student number, class, and major, not where the block ID, this is a block ID, or even the raw device like that, this is a disk. And sector number, disk number, cylinder number, no. User doesn't have to know about this one, internal level. Instead, just know what is a conceptual design. Student consists of the name and ID and the GPA, something like that. So I try to select the GPA from the student. At the time, it will go through this one, the major, check the major. So major will be stored as somewhere in your hard disk drive. Who knows that? DBMS knows. That is the internal schema. So DBMS should support conceptual schema and internal schema. Conceptual schema, who create the conceptual schema? User, like you. And who create the internal schema? DBMS software automatically. So as a user, you don't have to worry about the internal schema. Why we separate such an internal schema and conceptual schema? For example, student information is full of this. So the Unix administrator attach the new file system. So we can create. At that time, if user directly access the internal schema, they need to change it, or they need to know where the student information are stored. So users should change their program. However, when you separate this one, conceptual schema is defined as the student information has 1, 2, 3, 4 attribute. Then internal schema, DBMS manage. So at this time, it doesn't have to be problem. It will not be problem no matter what happens inside. The student user can still access this data. This is a conceptual schema and internal schema separate. The last one is external view. Can you remember the beginning of class that I mentioned? There's one real table, but it can be multiple view. Okay, how can we implement that one? We have one student table, conceptual schema, but it can be viewed as differently. This one is called the view. Actually, the name is a view. So view. So in database, it has a view. You can view as many views as possible. You can create the many view for specific schema. Okay? So like the student one view, or this is the student view for computer science. This is a student view for the payroll of this, but student table is still one. Sometimes this one access only this column, this one access this one access the whole column, something like that. When you insert the data, it will apply to the conceptual schema. But for the view, it can be view, sometimes not view. You can view some of the data, some we will learn later. But anyway, the DBMS supports three schema level, three schema architecture. First, internal level, internal schema, and second, conceptual schema. Third one is external view. So external view can be many. This one is just one, then internal view, it can be whatever. We don't have to worry about it. So that is the three schema architecture. Next week, we will finish the chapter 2, then we'll start the data modeling first. That is the ER modeling. ER modeling is not very complicated, not very difficult. Any question? Okay, thank you. And you let me know your extra point.